vocabulary material. This is a short tutorial. This time I will discuss atomic number, atomic mass, and atomic mass units, the periodic table of elements, and how to figure out the molecular mass of a compound. Let's start with some science. This is a bowling ball. Bowling balls are made up of stuff. That stuff is known as matter. The quantity of matter in the ball is its mass. Now, if you've ever gone bowling, you'll know that a bowling ball is heavy. But if you put it up in space, it would just float along. It's not heavy at all, because in space, the mass of the bowling ball does not change, but it has no weight, because weight is the gravitational pull on an object. The fundamental particle of matter is the atom, and it has two parts: a central nucleus containing protons that are positively charged and neutrons that carry no charge. Surrounding the nucleus is a shell of electrons, and those electrons are negatively charged, that negative charge balancing the positive charge that is carried on protons. Protons and neutrons are of approximately equal mass. Electrons are tiny. They are almost 2,000 times lower in mass than protons or neutrons. And so in the grand scheme of things, they don't really make a lot of difference to the weight or mass of an atom. The atomic number is the number of protons in the nucleus. Hydrogen has one proton and its atomic number is 1. Important to note, there are no neutrons in hydrogen. Oxygen has 8 protons and its atomic number is 8. The atomic mass is the mass of the nucleus, which is 2 times the atomic number, because that is the mass of the protons and the neutrons. So oxygen has an atomic number of 8. It has 8 protons, but it has an atomic mass of 16 because it is made up of 8 neutrons, 8 protons, and 8 electrons, which have vanishingly small mass. If substances bind together, the sum of their atomic masses is called the molecular mass, and that is sometimes called also the molecular weight. So molecular weight and molecular mass are used interchangeably. The atomic mass unit is measured in Daltons. The Dalton is used in chemistry to provide a unified measure of mass, the so-called AMU, atomic mass unit. And it is defined as 1/12 of the mass of unbound neutral carbon. Carbon has an atomic mass of 12, so an AMU is 1, approximately the atomic mass of 1 proton and 1 neutron, 1 atomic mass unit. 1 atomic mass unit contains 1.6605 times 10 to the power of minus 24 grams. The mass of 1 electron is 0.0005 atomic mass units. If you ever did chemistry in high school, college, or even picked up any kind of a chemistry textbook, you will be familiar with this, the periodic table of the elements. And let's pick a random element from the periodic table that you will be familiar with from the school textbook. This is helium, element number 2, and it is number 2 because that is the number of protons in the nucleus. 2 protons, that's its atomic number. Below this, you'll see this number here, and that is the atomic mass, and the atomic mass of helium is 4.0026, and that contains all of the protons, the neutrons, and the electrons in the atom. Atoms bind to each other to become molecules, and we are made up principally of the molecule water. Water molecules are made up of 2 gases, hydrogen and oxygen. And if you look at the periodic table, here is hydrogen, here it's element number 1. As its nucleus only contains 1 proton, and there is only 1 electron. The atomic mass is approximately 1. Over here you'll see oxygen. Oxygen is element number 8 and its atomic mass is approximately 16. The combined atomic masses of elements constituting a molecule is the molecular mass. So let's make some water. If you add two atoms of hydrogen, 1 plus 1, rounding up, plus one atom of oxygen, H2O, you end up with a combined molecular mass of 18. So the molecular mass of water is 18. In this first tutorial, I covered an overview of the course, the science of atomic number and atomic mass, the concept of the atomic mass units, or AMU. I also introduced the periodic table of elements and talked about how to determine the molecular mass of a molecule. Next time I will discuss the basic physical properties of water, how and why moles determine quantity, and how to figure out the alcohol calorie content of a drink.